I hope everybody can hear me. I see there are some non-German attendees, so now I hope everybody can hear me. And if not, please let me know. Then I can uh, uh, try to change my settings. Anyway, so let's start to right now away. Not all are here, but I think maybe they come later. Today we start with 3D, why 3D matters, why anyway 3D. And so maybe a short intro. We start with a short intro about 3D, then some advantages of 3D. Then we have a short comparison between 3D or 2D, or we step over that. I think most people know 2D, so you can see the advantage of 3D immediately. And what I really want to show you is, but only very short, the instruction set, which allows you to make solutions with the EyeVision software. This is maybe the most interesting part, I would assume, because this gives you the best feeling of the power behind of it. And then we immediately start with some solutions we already made or customer from us made with the EyeVision software, starting, for example, with bin picking, but many more. These are ready-made project files. So after the session, you will get the download link for the EyeVision software. This will allow you to, first of all, to test the complete EyeVision software with all the features, including image capturing, not only for 3D, but also for 3D. And more important, beside of the download link for the software, you get also the download link for the project files, which I show you later, so that you can see how to make the solution. This is one of the, in my opinion, big advantages of the solution, that you have for most of the tasks some projects which does similar things, so you only can or have to modify it to your needs. So let's go ahead. First, one word about EVT. So in that case, let's start again. Why 3D matters. Introduction, what I said to why 3D matters, advantage of 3D dimension, advantage of third dimension, 3D compared to 2D. I just mentioned it, and this is the slide for it. The EyeVision for 3D instruction set, 3D profile compared to 3D area, and then the examples. Okay, so I said we are working for 25 years, have roughly 60,000 sold licenses. These are our headquarters, our subsidiaries, and our integrator network. So, and here I realized, okay, I missed you to share my screen. Let's have a look if someone is waiting for to enter it. It's difficult for the moment. It looks not like that, right? Oh man. No, it looks not like someone is waiting. So, okay. So, what is the advantage of EyeVision? I just started at that, and to give you an idea, we have EyeVision not only for Windows, we have it also, as you can see, for Linux, on Intel CPUs or on ARM, and finally also on MIP devices. So you are free to choose on which platform you want to use the EyeVision software, including all the image capture and I/O functionality. So beside of this, we support, based on this, also smart cameras, where the EyeVision software is running. So we are not only dedicated to embedded system or PC system, you have also the option to run the software on any kind of, not any kind of, on many available smart cameras, so that you can do these, let's say, smart solutions. We name it either EyeCheck or EyeSense, depending on the instruction set. We have a special presentation about that. So if you're interested in this, simply have a look to the webinar about our smart sensors to get a full overview. From the sensor side, we support a wide range of manufacturers. So I will have a look, a short glance to the supported manufacturers in a few minutes, so that you get also an idea that you are not restricted to in the sensor manufacturers. So you can, I am sure, find all kind of sensors which fits to your needs. For 1D, 2D, 3D thermal and hyperspectral cameras, also through the full spectrum, we will have a short look later. Beside of all the image acquisition stuff, we support also a wide range of I/O systems, from bus-based I/O, which is more and more the common usage. It's OPC UR, Profinet, Modbus, EtherCAT, Ethernet IP, Ethernet, of course, UDP, Ethernet IP, UDP, also RS232. So there shouldn't be any problem to connect to any I/O. And of course, we support also different kind of I/O boards, which you can plug in if it's a PC directly into the PC, or you connect it over a bus system like USB to the, for example, embedded system, to have direct PLC I/O. And of course, if you have a smart camera, or your used camera, or the sensor you're using has a dedicated I/O line in the center, we also support that. So many 2D cameras nowadays have some I/O lines, especially for the trigger, and maybe one or two I/Os. You can use them, of course, also with the EyeVision software without doing any additional programming. So today, our main focus is on 3D, okay? Beside of 3D, we have also 1 and 2D. And to give you a bigger option and more versatile solution advantage, we will also have a small, very small glance to AI, because the combination of not only 3D, but also 2D and AI will enable to do things which are really difficult to do it without these options. So one short word, we have a special presentation and webinar which is also recorded, and you can watch it, about the AI and how to use AI with EyeVision. So what I only want to say, okay, we have this AI and we have a lot of pre-trained networks, which makes it very easy to use AI. And so if you want to do something with AI, mostly you can use a pre-trained network, and you are much faster to make the solution. Either you instead of starting training by a scratch network, using one fitting network, and do a transfer learning also in the EyeVision already integrated. So a short view to our comment set, we will see it later, so I won't mention it again. The main instruction set consists of everything what you need to control, from the image acquisition to I/O and also robots. But today we will mainly have a look to 3D, and therefore we just skip or go one step ahead. Here we have overview, or important for us. We have separated it in two parts, the so-called profile part and the point cloud part. Profile part, if you operate only on, for example, one laser line, it's very often used if you use a laser profiler and you do the evaluation on each line, or in many cases you use a camera and a laser line to make your own profiling setup, and then you can operate on these profiles. We will have a look to these examples also later, and as I mentioned it, you can download it at any time, so that that you can test it by yourself and see how you can use it for your tasks. So you see we have a real large instruction set only to operate on profiles, everything from measuring to fitting of profiles and so on. What you can do, I really want to show it to you with the project files, and then we go to the point clouds. The instruction set is somewhat bigger, as you can see, of course, because the point cloud allows you to do much more with 3D. And of course, you can always combine these instruction sets with the originally mentioned instruction set for the 2D, or that means if you have to operate or you have to read some stuff, OCR on 3D point cloud, you can use, of course, the OCR tool from the 2D or from the machine learning part to do your code reading, OCR reading. Of course, for the barcode, DMC codes or whatever, you use the associated code reading stuff. So if you have a look to the first, you see here the code reader. You can combine the code reader with the 3D, of course. And of course, you can use all the communication stuff or the statistic in combination with the 3D. So here we are. So the next would be the image acquisition, or let's say sensors. In many cases, it's the question how many sensors are supported. We have right now roughly 130 supported sensors with different manufacturers. So you simply, also with the demo version, that's why I recommend always the demo version. You simply can do your tests with the sensors if you download the demo version and select the manufacturer and follow the steps of the hardware configurator. I will have a short glance to the how to install hardware later, but as always, I really recommend our iAcademy. If you go to our website, you find iAcademy, and there you find a lot of videos, for example, on how to install the EyeVision software by scratch, how to install the project files, which I recommended, and how to select a hardware which you want to use with the EyeVision software so that you can test it. So that means if you have any kind of the supported hardware here, I really recommend simply download the software, select your hardware, and simply try to capture the images. If the hardware is, if we don't have a direct support for the hardware, that means that we have the native integrated the native API. You can always try if it's a GigE or GineCam compliant GigE Vision camera which are most of the 3D cameras, you simply can use this one, especially with the latest profile of the GeneCam GigiVision. You should get immediately also a point cloud. And if you have a very rare sensor, which we don't support, let us know. And mostly we, if there is some need of it, we can integrate it. It always helps if you try to download the latest version, because we still continue to integrate more 3D sensors or sensors in principle, so that you have the option to see that maybe a sensor which is not already integrated today, you can use it tomorrow because we are already done it, or you let us know and we try to do it. So this was the, I hope, not too long intro, and I wanted to start with some examples. Let's say we start with the palletizing and depalletizing project here. Therefore, I would show you first a short video, and then I show you the how it works in the software, and we have a close look to how it's done. So why I start with this one it's simply because it's 3D and AI. So sometimes you have to palletize, depalletize, recognize objects, move it from one position to the other. So we have here a small robot, but as you saw, we support different kind of robot manufacturers like UR, KUKA, and so on. So you can use any of the robots, even no-name robots like this small one here can easily be integrated, if it's not integrated, to work with the EyeVision software. What we see in the next step in the EyeVision software are only the pictures captured and captured while the robot is operating. Here, so maybe you can this I didn't check it that there's some music in the background. This is a standard video. Here you see how the robot is operating. Here some more examples. I only want to show you the robot that you have an idea what the software is doing right now. And now let's switch to the EyeVision software here and have a look exactly to this operations now. We see here on the left side, this is a robot. And here, this is the image we just saw in the video. And with the AI, we do the object recognition. In this case, we recognize, for example, the SMIN, the MOIK, Ricola, and so on. And then we use the 3D to determine the grab position. Of course, if the boxes are always flat, maybe you could do it with a 2D camera. But the really advantage is here, the boxes could be in any angle because of the 3D. We get all the 3D information. As you can see here, this is a real 3D image. So we get beside of the height. So that means here we have two boxes above. We get the height for the grab position, but we would get also all the angles. And if I start it, you see here how the software is working. Now he recognizes it, then the robot grabs one, and the next one which he is recognizing it, then he grabs it away, places it here on the SMIN stack, and so on. And so this is you can download this example so that you can see it by yourself how it's done. If we stop it and if we have a look then to the configuration window, you will see here we have these 2D image where we do the recognition. And of course, we have here also the 3D images. And here you see the complete 3D image for the on which we are operating. And of course, here we see always also the robot base from the roboter. And you see here, you can do different nice, more or less nice menus. You are free to position them and make whatever you want. And finally, the interesting thing is here on the left side, you see here, this is instruction set. And of course, this is the complete program, which does the or recipe. It's more a recipe than a program because you only use the tools from the toolboxes here to operate on the point cloud. And of course, for the recognition, you use from the machine learning toolbox classifier and object detection recognizer to recognize, for example, Ricola or whatever you have trained. If you have any other box, either the system can simply recognize it without any additional learning, or you simply use the training tool inside of the EyeVision software to do the training. But the main task is you don't have to go deep inside of how to do it. So as you can see here, you simply use the image acquisition tool. In this case, because it's an offline version, you see here, we load the images from the files. So if you was on one of our exhibitions, you could see that the robot was working. That was the video which I showed you before. You see when the robot is running, you simply use the snap from camera. This means we capture the image from the 3D sensor in this case. And then to prepare the demo, we save it, or if the robot is only running, we simply activate the capture image from here, and then the complete recipe is running, and you can see how it works. Of course, we deactivated the robot actions because we don't have here in the demo the robot, but in reality, you simply activate the robot commands again, and the robot is running. So what we want to show today is that we have very simple, of course, it looks a little bit complex, but if you compare it with C++, it's really easy to make this solution from recognizing the box to send over the complete coordinate set, X, Y, Z, and all the angles for the robot to grab the part. With the download link, it's very easy for you to simply understand how it works. And if you have, or if you want to do a similar task, you could use this one and adapt it directly to your task. I could now go through all these comments, but I think it makes no sense to simply go step by step to it. It would only be boring. You saw it's working. Of course, you can make some menus with statistics and so on. We will see some more outputs later in some other demos. So I don't go too detailed to this one here. Maybe you saw this camera viewer tabs. You can you have the options to view all the different images from the sensors. In this case, the sensor generates a color image. This is this one which we use for the AI, on which the AI recognition is realized. And the same sensor also generates this point cloud here, which we visualize here. So you can also make it bigger if you want to see it. And you have all these different images. if the camera also, or the camera, in this case, this camera also generates a depth image. So you could also visualize that or operate on the depth image, either because you need some depth information for, let's say, a 2D tool set, which you find here in the first section, or you want to do some code reading or whatever, which is represented in the depth image. You can simply mix it as I mentioned it before. Or finally, use the 3D image to do the 3D evaluation to find out, because we recognized the box here was a deep learning tool. We could simply go to this position. If there are more boxes, whatever you saw before, for all the images it works, even if there are multiple, then because this box is at the same position like this, you can either you have a sensor which generates both images, the color and the 3D image, or if you want to use two cameras, which is also possible, you can use, for example, a color camera and any time of flight sensor, which generates you a 3D point cloud. And in this case, you have to register the two fields of view to that. If you detect something in the point cloud, you can go to the color image or vice versa, like we did it here. You see in the color image, okay, with the AI, we recognize the Ricola box, and we can go to the point cloud, and now, okay, this point cloud belongs to that image. So if you have a camera which is registered, you don't have to think about it. If you have two cameras which are not registered, you simply have to register it. All the tools are already in the EyeVision, and you will find also an example for the registration, so that it's very fast and easy to do it. And this is one of the tools. We just ran it. So if you want to run it again, you simply can go to the process mode, and then you see here, if you press the start button, here recognize the Ricola, and then now it's empty. Next thing is, we reload everything. You see also the hand which reloads the packages back, the parcels back, and then immediately it starts to recognize the boxes, and based on the height of the box, the grabbing is organized. So and therefore you see all everything what is behind. You had a short overview how it's done, and if you have downloaded it and have questions, simply let us know. We are always happy to help you to make a solution based on that. So let's have a short look to our presentation. Okay, we just had a look to the robot solution here. This one. I made here. I stored an image here. You see, for example, the Ricola has this tilt angle, and in this case, the robot will also use this tilt angle to grab it. That's why 3D is an advantage. In 2D, you wouldn't know which angle it has. Of course, if you have a suction gripper like here, in most cases, you simply can press it and hope that it holds. But if you use the full 3D command set, you can tilt because you know the angle, you can tilt the suction gripper so that you are in a 90 degree when you grab the part. So another nice solution solution which we made is a PinCheck solution. So you simply scan any kind of connector. You can train it with the golden part, and based on that, we determine the height and the tumbling circle, and do a full measurement. You get, depending how you visualize it, you get the result of the pins. Here you see for each pin which is detected, the position and the height and the tumbling circle. And if there is a fail, you get also exactly immediately the resulting pin, which failed. In this case, it's pin 17. And how does it look like if it runs from the EyeVision? So as I told you, if you download the projects and follow the instructions, you should copy them to our project folder. And now we could simply use the PinCheck offline demo. Offline means no hardware here, like from the robot. And we simply reload now the next demonstration, the next solution. So this is a real solution. And after it's loaded, you get the main window to start it. So you are free to use the GUI designer to build your own GUI. This is a more simple GUI. And here you see we load the different images, and we do then the inspection. Here, each time if the part is moves, we capture the new image, and we do the evaluation here on the image. And once again, if we had a look to the configuration, you will see again here the two different images on which we operate. And here, this is the recipe which does the evaluation. In this case, we do the inspections in the different sub programs here, which we call. So that's why it's a little bit short. But if we have a look to them, so they are already loaded, as you see. Then you have here the tools, the 3D tools. That means this is now finally the real program which does the 3D inspection of the pins. So this recipe is really small, as you can see. And of course, here, this one is only needed to organize everything. That means, first of all, as you see, we do capture CKP. This is the subroutine capture. And here you see, once again, only either you capture the image from the 3D sensor, or you simply, as we do it right now, we load the already captured point clouds directly into the image memories. The final good thing at this, because all operations are on image memories, the software cannot decide, does this image come right now from the sensor, which is connected to the software, or is it from the hard disk? So you really can make only a short program which captures the images, and then you can do all the programming offline without doing the capture, and without having the sensor on your hand. So you simply can operate on the point clouds. And therefore, you have this evaluation. Of course, we have some special commands here to grab the golden part, store the values for the golden part, and so on. That's why I really recommend simply download the example and have a look to it to get a deeper insight. Let's have another look to one of our examples. This is our meat slicer, or the EyeSlicer. Here we cut meat. First of all, we scan the meat, and then the meat is cutted. And based on the complete volume, this is done with 3 sensors. there is a small gap you see here, so that you can get all three sides of the meat, and then the software runs on it. So I would also show you a short video that you have an idea how uh, how it works. So I think we don't want to have the complete intro. I switch off the sound here, and here you see the incoming meat. It's scanned completely, and the next step is then so it's an endless. Nearly endless meat. The pieces are connected together, so it never stops. And after the scan, in this case, this example, after the scan, we get then the complete operation. And you see here, based on the calculation, the cut is made in the different meat positions. So let's have a look how it looks in the EyeVision software. Here we are. Once again, you simply open the meat cut project. This is not in the webinar sample. This is in the normal 3D area examples. So we have this meat slicer project here. You simply open it up, and you see here, okay, so we are ready. And now you can run it, and you will see the results here. Of course, here we calculate the cuts on the meat. This is the point cloud of the meat. It could be not only meat, it could be fish or whatever volume you want to cut. At the end, the 3D tools don't care about what kind of stuff you want to or have to cut here. Once again, here we load the point clouds because we don't have the machine here, and based on the loaded point clouds, we do the evaluation of the meat piece. So of course, I didn't mention it. You can also put a rainbow surface, so then it looks more than a complete piece of meat. And as you see, also the solution recipe is not very big. And in this case, because we didn't make a nice or whatever a menu, we only did the calculation and show this in this overview. The program is very short. Of course, you can add here also some nice menus with buttons and statistics, but simply to show that it's very easy to make this kind of solutions. I have added it here. Yes. And let's have a look to the next step. So as we made the palletizing or depalletizing solution, we could also do this bin picking stuff. So I just mentioned it also. We have a real flexible robot integration. So you can use this small robot, which we have, as long as he can handle the weight, or you can use any of the other robot manufacturers, which we already have implemented, or we have a real flexible interface to the robots, which allows you to add more robots to the needs, to your needs. So simply, if you have any questions about integrating of a new robot, let us know. We are happy to help you if it's if you have any questions for that. So finally, also in this case, we have the 3D sensor. In this case was it's a not a Photoneo, but you could use a Photoneo, of course. In this case it was a NASA sensor from Percipio, which has similar resolution and similar field of view. But the availability and of course it was done in China. So in China it's much easier to get this kind that sensor because it's Chinese-made sensor. But you get it also here in Europe. So let's have now some more looks, closer looks to some other examples. I also already mentioned so all what I showed you until now is was 3D areas solutions, but of course in many cases it's totally enough if you want to do some simple inspections on maybe you want to measure a gap. So you only have to do some measurements, some simple measurements directly on one laser line. In that case, it's not really necessary to do a complex work. So we captured here with the triangulation scanner this part, and here we do the measurements on this part, so that you see here. Let's have a move, and I think if we put surface mode on, if we run this, you see here, this is like when the triangulation line runs over the gap. We get all the gap spaces, and we do the gap measurement here, so that you can run it in real time while the scanner is running over the example. This is one solution for a profile. In this case, of course, you could, as you see, we have here the point cloud, and with the special, we load this point cloud, and then we have here this tool. Normally, you can use this tool to capture it from a camera, or if you want to simulate it, or if you want to do the offline programming, you can extract the laser line. Mostly it's a laser line. So let's say you can extract the laser line or the line out of the point cloud from a point cloud, so that you can simulate it. We have, as I mentioned, we have a real large number of tools to operate on simple profiles. We also so normally the laser line the laser line looks more like that, because of course the camera cannot see these 2 points. To enable or give the user a better feeling about the outlook of the part, we generated these lines based on the information we have, so that you have always an overview. Here you see also you can add your results to a statistic menu. We have different statistics, but this one here would generate also immediately the CPK, or calculate the CPK and this other stuff, so that you have immediately information which you might need to solve your task. The same is here. That's why I said I really recommend you simply go through. You will here, I think this might be a nice demo, or one example. We will see it in a second. So we already load the so for some reason we need the laser line here, this one here. Okay, now it's here. So this is didn't I say okay? I did say okay. Now we should simply see the laser line. Here is the laser line. And so we load, this is a real weld. And of course, as before with the gap, here we load the laser line. And you see here, if I run it, how the laser line is running through the surface. And here we see the how this profile looks like. And we do have the profile matcher here, which simply matches the expected profile, which we search for whatever. You can use it for weld, but in many cases you have these glue or seal stuff, which is extracted to a surface, and you only have to see if it's okay. And the interesting thing is here, if you go to the surface, you see here for the anomaly. If in this case, for example, if you have an anomaly in this shape, we collect the shapes with the anomaly to the defined shape, and then we get, in this case, a point cloud, and we can then do some additional evaluations like, is it concave, convex, how big it is, how big is it, and so on, to do some additional evaluations on it. This will help you to do the full evaluation. That means mostly if you have concave error and there are multiples of them, you can define, okay, this is not good or bad, or if you have a gap or whatever. And you simply can run it here. It runs complete through the point cloud, and then you see all the evaluations here in the field of view. And it's easy for you to simply see how it would run in reality. Let's have another look, maybe to simply to show you also some other 3D examples. A simple bin picking example with no AI. So we have this here at the end. It's exactly the same. So we have a box with different parts inside. Unfortunately, I don't have the images of the part. So we recognize now the part. We realize, okay, we have a bottom, front, left part, top. And in this case, we also check the airspace above the part, if we can pick it out of the box. That's why you see these boxes. That means wherever the box is, we could grab it. And you see here, the main task is to use the 3D matcher here to match the part. And after the matching, we simply check, is there enough space to grab it out of the box? And of course, you can run it again. And each time you run it, a new image is loaded so that you can see, okay, how do I do the solution if I have not so complex part like with the robot grabber with the AI. So in many cases, use simple 3D matching is enough to do the solution. It depends on the task you want to solve with it. And maybe let's have a nice other solution, which I really like, is the cap inspector. Maybe you saw it already, but it's simply to give you an idea. Even if it's fast, it works very good. That means to do the cap IBC cap or can inspection. These are the top of cans in the production field. They run with 30 parts per second, and we determine in the cans if the pressure is there or not. So you get with the full speed here. Of course, this is really like the speed in the production line, and you see here only a few tools are needed to make this kind of application, and it's not a real big deal. And you cannot do it in 2D because you see only a flat surface, a gray image, and you don't know how the height, especially at this point here. This is the height of the can, and also determines the pressure at the end. So what I really can recommend at the end is that you simply go download it, try out the software, and simply find out if it fits for you or not. You can use your cameras, of course. And if you have at any point questions, simply send us an image or how to make it. Image is always good. Image in this case means point cloud, of course, so that we can operate on it. I highly recommend, if you do something with the EyeVision software, scan the part or grab the part with 3D sensor and save it and send us a complete project. So if you do something, there's also a short video in our Academy, how to make a project. It's not very difficult. You simply go to the project and make a new project, follow the steps from enter the name and so on, the wizard here, and you get a project, and simply send us a project with some point clouds inside, and then we can help you to make the solution. What I wanted to say, of course, if you are interested in the in the hardware which is supported, of course you can always go to our website. But if you go here to the application parameters and the hardware, you simply can select or see here all the different manufacturers which you can directly use. You simply select the hardware you have on your side, follow the instructions here, select it, and instead of offline, you can select, for example, Micro Epsilon or Percipio or Photoneo or whatever. And you can immediately use the sensor if you follow the instructions how to install it. If there is a device which is not supported here, you can try to use the GeniCam implementation, which might work. So normally, if it's a new sensor, you can use EyeVision, and with our consumer, you directly can access the sensor and get a point cloud in the image memory. If the sensor supports more than a point cloud, means it supports maybe a color image, a point cloud, a depth image, and some other, you get it in consecutive image memories. That means you can simply add here automatically additional image memories, and for whatever you see here, we use already in the background some image memories. Might be the intensity image of the sensor, I assume. I have to check it. So you have all the information of the sensors ready on your fingertips to work on it. You will get the latest version from the EyeVision software on next Monday. You can download it today. Then you get the current 4.4. But on Monday the 2nd, we release a new 4.5 version, which has some new features and, of course, some additional hardware manufacturers. We added some like sign vision and I just forgot. I just had it in a minute in my mind. And Next Vision. These are two manufacturers who develop also triangulation sensors, which are really powerful. We have another manufacturer right now. Maybe it meets also the next release, which has these confocal sensors like LMI as an option to the LMI sensors. So as you saw, we have LMI anyway in the software, but we are working that you have always a choice to select the camera manufacturer. I just mentioned before, only shortly, that we have a lot of communication protocols. So if you want to check it out, you find it here under communication. Simply have a look at it, what fits best to your needs. Yes, this was a short overview of 3D. Of course, as you can see here, we have a lot of tools. It's not possible to simply remind all of them in this 1 hour. But if you use the project files which we have, I'm sure you get a real direct insight what you can do with the different commands, and of course, or which commands fit to what. And of course, you have some demos so that you don't have to start from scratch for your application. And in any case, you are always welcome to request our help. So with this, I would close the session for today. If you have any questions, simply feel free to send us a mail. And yes, to send us a mail, and we will help you. Thank you very much, and I hope to see you soon. Bye-bye.